live. Let's see. Wow. Hey, everybody. Thanks for joining us again. It is Thursday. Jim and I are on. Everyone who's coming in, thank you officially for those that are just coming in and the future peoples that watch this know that Michigan UFO sightings, Wayne was the first guy in the chat today. And not that we're keeping track. There'll be awards later. But we have a guest tonight. Dakota's joining us. We're going to get into, well, not only there's a reason. He does astronomy, among other things. Just consider him a Renaissance guy like the rest of us, and you all that, have your, esoteric to scientific research. This is going to be a great night. And I was going to wait to let Jim talk to Dakota. We haven't actually done this before with him, but we have been, Dakota and I, in person at his observatory here in Utah, and we got a lot to do. So Dakota, thanks for entertaining us for this evening.
Thanks for having me, Jared. I appreciate it, and thank you, Jim.
Yeah, and I don't know if Jared mentioned, but I had about 2+ years on Kitt Peak as a docent. They have 22 optical telescopes. I think everything from about a 12 inch to a 4 meter, the Mayall. But I haven't. I left there 2018. I didn't like the new volunteer coordinator, so I left. And unfortunately, she's still there. But Kitt Peak has been closed since they had a wildfire go through there here about 18 months ago. Crazy. And the state hasn't put the barriers on the side of the road. I mean, because it's an 8% grade minimum, and it's nothing but switchbacks up from 2,000 feet to 7,000 feet in a relatively short area.
Mm-hmm.
But the telescopes up there were incredibly fascinating, especially the Mayall, because I've climbed all over. I've been inside where the primary mirror is. I was actually there when they took it out to recode it because they modified it to do they're looking for dark energy using the Mayall, where they replaced the secondary mirror with 5,000 individually adjustable lenses that go into a spectrograph, and their goal over the next 5 years. I think that first light was in 2022 because of COVID. It was slowed down quite a bit.
Right.
Yeah, they'll be. They have first light, and they expect over the 5 years that they've been funded for that they're going to look at and analyze 40 million galaxies to try to determine what is dark energy and dark matter. And there's a telescope in Chile that's doing the same thing. So they're getting both the northern sky and the southern sky. So, and if you can go online and get information, anything that's been collected, they're going to release it within 24 to 48 hours. So I think it's DESI, DESI.
DSI. Okay.
Yeah. Going to Kitt Peak National Observatories and just look at the Mayall, MAYALL. That's the 4 meter. That's the one that's looking for dark energy. It's really fascinating. I know when I first interviewed, was going there for an interview for be a docent. I asked the lady at the front desk, "Do you have a quarterly magazine or a monthly magazine on this?" "Oh, sure." She hands me it. I gave it back to her. I said, "I need something written in English." I got good grades in math and science way back thousands of years ago. But I look at this, I couldn't tell you all it was is a bunch of scribble as far as I was concerned. And
that's Jim, go ahead.
Yeah, I ran into never mind, forget it. Go on.
Well, no, I wanted I think you talking about that observatory is still really fun intro to Dakota. Do you want to tell everyone a little bit about, well, I don't know, somehow do all of you up through how you built and assembled and have an observatory?
Yeah, no problem. Depending on how deep you want to go. It's kind of fun. I mean, I'll start out by saying, we have an observatory. It's open to the public. We offer tours to the public, and the observatory is actually situated in a hotel, which is kind of fun. But we're all just a bunch of amateur astronomers out to have some fun and see some fun things. And really, with us, our journey's just begun. We're no nationally funded or large funded observatory like Kit Peak Observatory, or any of the big ones like Keck on Mauna Kea or anything like that, but we sure have fun. I'm originally from Utah. I'm just truly a kid from the mountains, a ski bum from Utah, and I've always been curious about the world around me. And it's interesting because I guess one of the parts of this journey that's probably significant is about 14 years ago, I got on Weber County Search and Rescue. So it's our county's search and rescue team, the high angle rescue team, where we do the rope work to rescue people who find themselves in a pinch in the mountains. And there was a gentleman on the team. He remains on the team, and he's a physicist and professor at the local university, Weber State University. He's a great guy. Jim could probably appreciate this, but he's a physicist. He worked on the shuttle missions. He later helped develop the infrared laser guidance system, that thing that hangs off the nose of the front of the Apache helicopter. So he was part of the team that developed that first piece. He's always been interested in astronomy, and he also runs a program of high altitude balloons, which
he's the one, huh?
Yeah. Yeah, I was gonna say that has a whole new meaning to it in the last month or so. And I've been out on some of his balloon launches, which is fun. So when I got on the team, he took me under his wing, and he started teaching me a lot, little bits here and there about science and astronomy. So I kind of had this seed had been planted, and I had interest in all of that before. And over time, we, as a family, we've got several family businesses and, small businesses in the small town of Huntsville, Utah. And it kind of just worked out that what eventually came to be was a hotel in that space. And the idea was to honor the history and heritage of the area around, where there's a lot of ski history, a lot of agricultural history in the area, and other, among other things. And the building itself was built to resemble a barn. And in the corner, there's a grain silo looking feature. And when we were trying to figure out what to do with the grain silo feature, I mentioned to my father, who's one of the owners, I said, "Hey, you know what that grain silo, the top of that dome looks like?" And he shrugged and he said, "Oh, no way, no way. There's no way we can do that. It's going to be over budget." I said, "Well, if we can do an observatory and it won't be over budget, will you let me do it?" And he said, "All right." And I came in a little over budget, but I designed it, and it came out pretty well. So it's a 14.5-foot dome that rotates 360 degrees. It sits up on the third story of this building, and we have an isolated pier that goes all the way down under the ground, with a nice sturdy foundation. So this pier stands up about 23 feet up into the air within that column, and holds up our largest telescope. Our largest telescope's 16-inch aperture, so it's nowhere near the size of like the Mile that Jim mentioned, but it's a fun telescope, and it's bigger than most amateur astronomer telescopes. And the significance of it is it's a Ritchie-Chrétien. So most research grade telescopes that you find are Ritchie-Chrétien, and what that means is they're a compound telescope where they have mirrors and optics, mirrors and glass to create the image. And Jim had mentioned a primary mirror and a secondary mirror. So the primary mirror is what you refer to when you're talking about your main aperture, and then the secondary mirror. And there you go. That's a good picture.
That's exactly what this looks like. Yeah.
And the primary mirror is your largest mirror, and in this case, they're called hyperboloid shape. So it's a special shape that helps conduct research better. Like if you're pinpointing two stars within your field of view and you want to know the apparent distance between them, it doesn't shift like it might in other telescopes like Schmidt-Cassegrains and others like that are paraboloid shaped mirrors.
Dakota, as much as you want to tell people about, if you want to name off the hotel, where it's at, but if you want to, feel free to mention anything you want about the hotel as we're going, so people can know that this is someplace they can literally get to. And as opposed to just shining off later, feel free to name the spot. But then also, just as a starting point, it is kind of unique, just the height. What's the elevation in Huntsville where it's at?
Yeah, the elevation is in Huntsville, it's about a mile. So we're just shy of a mile in elevation. And you kind of touched on that. The idea is astronomy is best done on Earth in dry climates where there's not a lot of rain. You want to avoid, obviously rain and clouds that are going to be in your way of view. So places where there's a lot of sunny days are a good place, and Utah's a particularly sunny place. Most of the time, we don't even get. It's funny because Utah's the second driest state in the nation, and when you tell people that, they usually think, "Oh, well, Arizona must be first." Well, Arizona's actually not first. Nevada is, and Arizona gets more rains during the monsoon season, than Utah does. So typically, it's a pretty dry state. So that's one of the things that makes it a nice place to be located. Like you said, we're also fairly high in elevation, being just over or about a mile high, which is fun. And then we don't have the high humidity of a lot of places. So typically you're seeing qualities pretty good, and you avoid some atmospheric disturbances that you would have in other places more predominantly.
Well, that also helps with technically speaking, for those into the technical side, no matter what size telescope you have, starting at that height really helps a lot. So there could be a mile lower telescope, but they're going to have to compensate for the height and those variables, right?
Yeah, there's about 15% less atmosphere at 5,000 feet than there is at sea level, right? So that just means there's fewer molecules, less atmosphere for you to cut through before you get to space.
So we are going to talk about some of the cool things you've been doing, and on table, without not really detailing it for those listening, I am very interested in what the satellite imaging and your thoughts on hey, we said there was a Big Bang Theory, and oh wait, there's fully formed galaxies, really not where they're supposed to be. I want to get into both, but I'd rather just table where I thought we'd go with him, Jim, and at the same time, in describing this, I mean, I could geek out pretty much the whole conversation about just the fact that you thought of putting on an isolated pillar. You have other telescopes there, so wherever you want to go, I guess. What are some of the things, along with the galaxies we weren't supposed to find, which I don't think should be the only carrot dangled? What are some of the things that you've been interested in? You've talked that you've looked at with this telescope, and also you threw some things out at me when we met about some very odd and strange planets. And there's everything for you to just feel free to start talking on it, and Jim and I will just interrupt.
Okay, no problem. Well, and you guys are smart guys, and I've seen, like I said, Jared, a little bit of your work, and so I know you guys can bring a lot to the conversation, that I may not know. So that's what's fun about these things, and we'll see where it goes. Yeah. I mean, in short, with our telescope, we're still working on our workflow, in all honesty. So, like I said, we run public tours that people can come on a regular basis. It's Compass Rose Lodge is the name of the hotel. And that's compassroselodge.com. The observatory is Halo Observatory within the lodge. And I got a couple of guys that are both retired. One was a 22 engineer, so he's just like super geeks out on astronomy. He loves it. He used to work on the F-22s. We have another guy who also was an F-22 engineer. So I got two guys that kind of work in the observatory that were F-22
Hey,
engineers.
Jim was in the Air Force. This is lining up.
and then our third guy is actually a retired nurse and also just loves the stars and loves interacting with people. So as far as tours go, they last a little bit over an hour. And what you can expect in a tour currently is we take you up into the observatory, and clear skies permitting, we show you some of the season's best things, right? And that's you can see some of the imagery we've taken with that Richie Chrétien that I told you about, as well as the Edge 11, which I think you mentioned. It's an 11-inch telescope that's great for viewing. And so we view things like any planets that are up, Saturn, Jupiter, Mars. We'll see the Galilean moons. We also like to look at, in the winter, the Great Orion Nebula, Andromeda Galaxy, and things
And in
like the
March,
Lagoon Nebula in the summer.
are you guys
And
doing anything with all the planets coming up at the end of the month?
pardon me?
Apparently, like 5 planets are all going to be viewable. Venus, Jupiter. There's like 5 planets coming up in 2 weeks.
Yeah.
Like,
So we're looking at the planets every night, right? Right now you can see Jupiter and Venus really well. It's funny because Jupiter is usually really bright, and as you look tonight, or within the last week and upcoming, you'll actually notice Venus appears higher in the sky now than Jupiter, and Jupiter's a little bit lower, and it's getting low on the horizon now, so it's a little more dim now. So Venus is actually the really bright one right now. But yeah, it's fun. You can always see the different planets line up, which is a lot of fun. And then beyond that, the human eye certainly has its anatomical limitations, right? So beyond that, we have to rely on sensors, cameras to see things in deeper space, right? So some images we've taken are like of the Triangulum galaxy, several million light years away. So it's kind of fun to see things like that. That you see these images, and that light that you're seeing from that is millions of light years away, which is fun. And as we continue to
wow.
tune our equipment and develop our workflows, we're going to be able to take longer exposures and see deeper and deeper into space. So that's what's fun about that. And we've invested in some additional camera equipment lately to have better photo capturing capabilities for 2 of our scopes. And I'm hoping that both of those are going to be online by late spring here, which will be fun. We'll be able to carry that forward. Beyond that, I know you mentioned James Webb and the discoveries. So important note on that, like we call our telescope actually like a mini Hubble, right? I think it's like we have like 1/36 the viewing power of Hubble, if you don't take into account the difference in the fact that Hubble's beyond the atmosphere. And then it's interesting because James Webb Telescope is, and I had actually written it down. It's the surface area of James Webb is it's over 6 times the surface area of Hubble. Which is interesting because that goes back to your high school geometry, where you talk about the area of a circle and it's pi r squared. So if you move from say a 1 meter to a 2 meter in diameter primary mirror, you're not doubling the surface area, you're quadrupling the surface area. So with the bit of extra, origami like folding out of the gold mirrors of James Webb Telescope, they've been able to obtain more than 6 times the surface area, which equates to more than 6 times the light gathering capacity of Hubble, which means that you can capture the same amount of photons in essence in a sixth of the amount of time as Hubble. Other significant things about James Webb is, one, it's farther away from Earth and there's atmosphere and the heat of Earth, so they can keep the sensors cooler, so they have fewer electronic disturbances for the sensors. And the other thing is they've tuned device, so it truly excels in the infrared spectrum,
Mhm.
which we can certainly talk about more, because that's really crucial to this conversation about the early universe. So that's some fun things about James Webb. So James Webb's like a super massive, very nice version of our telescope, and has some of the best light gathering sensors that man has created. So it's pretty a fun thing, and it's a great marvel. And I actually have a friend who's a nuclear systems engineer, and right when James Webb had flown up into space, he kind of gave me this, yeah, we'll see if it works. I'm a systems engineer, and it's got 400 and some odd different operations to make it unfold and work properly. And without, I mean, at least they didn't release it to the public, but it seemed without a hiccup, every single unfolding thing that needed to happen for the telescope to work worked. So it's pretty amazing.
It is. So again, not trying to jump to it, but on the note of galaxies being where they are, I don't know what do you think of what they found so far?
That's a great question. And here's the thing, my guess is as good as your guys, right? So I would love to hear what your thoughts are.
This is perfect for Jim. Jim.
Well, I don't know about that. I'm not an astronomer, but the telescope. I was really excited about the James Webb, and when the Hubble first went up, when they realized their optics were ground incorrectly, they were ground for a KH-11 spy satellite. That's what the Hubble is, with a different primary and secondary mirror.
Yeah,
that's the only difference between a KH-11 and Hubble. So if you go to National Air and Space Museum on the Mall and you see the Hubble, I think they have a KH-11 in there now. So it's basically a Hubble. The telescope I'm really excited about. I don't know if they've gotten first light yet. Is the giant Magellan Telescope in Chile, where they're using, and the mirrors were built here in Tucson at the Mirror Lab at the University of Arizona, but they're utilizing 7 27-foot diameter mirrors at 16,000 feet. So they said they should be able to look back within 100,000 years of first light in the universe. They'll probably have a for sale sign or a smiley faced emoji there somewhere.
that's a big light bucket.
Oh, absolutely.
No, it's super exciting. I mean, that's this, that's simple physics. The bigger the aperture you have, the more light you can gather, and the importance of, throwing a telescope up in space, because as far as Hubble goes, like as far as telescopes go, Hubble is not that big. But it's just difficult to get a big telescope up into space. And the key to getting the telescopes up in space is the fact that infrared radiation from beyond Earth, as it reaches Earth's atmosphere, it's absorbed by Earth's atmosphere. So telescopes within Earth's atmosphere cannot capture the lost infrared radiation. Does that make sense?
Yep.
So that's one of the key things to get them out beyond. So that's something that James Webb excels at. And I guess just for those listening, as a kind of recap of the Big Bang. The Big Bang, the name actually was penned by a gentleman named let's see, he was an astronomer. It was Fred Hoyle, and he was actually a skeptic of the Big Bang. So he didn't refer to the event Big Bang in a positive light. It was kind of a sneer at the idea. And in fact, when Einstein was working on his theory of relativity, it would have been general relativity in this case, Einstein assumed that there was a static universe, right? Because I mean, when we look up at the stars, there's no real apparent shift, visually to the naked eye. We don't see the expansion of the universe. So even in the early 1900s, some of the brightest minds in the world thought that the universe very well may have been static and not changing in size. So it was so he actually penned what was called the cosmological constant to the end of one of his equations to basically stabilize the universe on paper. Say, okay, well, let's add this constant because we need to make sure that this universe is stable and not growing or shrinking, because the math doesn't lie. And the math was telling him, hey, according to your theory, the universe could be growing or shrinking. And he's like, oh, well, let's throw this dandy little thing on the end and mathematically account for that and say, okay, it's stable.
That's just
And
so
then
stupid.
which is funny. And then later, Edwin Hubble, the namesake of the Hubble Telescope, he was another astronomer, and I think he was working in California at the time, maybe on Mount Wilson, if I'm not correct.
I think you're
Um,
right.
he discovered, I mean, he didn't discover Cepheid variables, but there's these variable stars that are constants, right? It's either the duration of time, between peak and valley, and the period of time that the variability in light occurs relates to the brightness of the star. And based off of that and other techniques used to figure out the distances of these stars, you can start to correlate the different things, the brightness, the periods, and other ways of which we've figured out how to measure the distance of things. He started finding Cepheids in what was then known as the Andromeda Nebula. And let's rewind and talk about what nebula. A nebula is a cloud of dust and gas, and there are many nebula within the Milky Way galaxy. Orion Nebula being one, Lagoon Nebula being another, and there's this supermassive nebula out that way that we called the Andromeda Nebula. And so he discovered these Cepheid variables within that nebula and started working the numbers out. And he's like, whoa, wait a minute. This is way farther away than what we thought. And so he discovered that Andromeda was not a nebula, but in fact, his calculation, I think, was about 100 million light years away, but, or maybe
Wow.
no, it was about just shy of a billion light years. Sorry, 100 million. Yeah. And then, it turned out that it's several million light years away. Right. And, so he discovered that Andromeda was a galaxy in of itself, of or greater than the size of the Milky Way, with many hundreds of hundreds of millions of stars, right?
Yeah.
And then that from there came the Hubble constant, right? He started to figure out, wait, things are moving away. The universe is way bigger than we thought it was. And this comes down to Doppler effect. It's when you hear a car come by, or it's how they, and Jim could, I'm sure, tell us a lot more on Doppler and radars and that, because that's how Doppler radars work. But the way it works is if a car's coming towards you, you hear the sound compress. So you hear it go, and then when that car passes away, it goes, and you hear that pitch lower. The same thing happens with light. If you have a galaxy that's moving towards us, it's called blue shift. The wavelengths of that electromagnetic energy, the wavelengths of that light gets compressed so that the light in wavelengths looks more blue, thus the blue shift, because we're talking about the rainbow here. It starts to go to the blue side and then ultraviolet side. And then when things are moving away from us, the light in same fashion, but the opposite direction, the wavelengths stretch. So you'll see light move towards the red. And so that's what redshift means in astronomy. And what Hubble discovered, sorry, this was to make a short story long. What Hubble discovered was
That's
that
our show. You're good.
most of the objects in the universe were moving away from us, right? And that's from our apparent field of view, or from our perspective. And really, it's everything on the whole is moving away from one another. There are exceptions to that. We are actually on a collision course with Andromeda, and we'll clash into Andromeda in a few billion years, but as a whole, most things are moving away, and that is the actual expansion of space. So back to the question on the Big Bang, which is, the devil is in the details on these things, unfortunately, or fortunately. But we're pretty darn certain that things are moving away and that the universe is expanding at this point. And one fun thing that goes back to Einstein again, when Einstein found out that Hubble discovered the Hubble constant and discovered Andromeda was another galaxy and discovered this redshift, he said, "Oh my goodness, it's my biggest blunder," or at least it's rumored that he said it's his biggest blunder. So he basically rewrote the thing, and then it's funny because it actually explains or helps explain dark energy fairly well. And that's what's funny. I mean, we're truly in the dark. What we do know is that the universe is expanding. We know that it's expanding at an ever increasing rate.
Well, what about,
We don't quite know. I mean, time will tell, right? We think it will, continue to expand for a very long time. And as far as the Big Bang goes, you think of it being like an old video reel, right? Like if you play the video forward, you're seeing the expansion of the universe. If you hit rewind, we come to this idea where we're pretty darn certain that all collapses down into something we call a singularity. And a singularity is that's where math, that's where numbers, that's where physics and everything we know just breaks down. So 13.8 billion years ago, there was the Planck epoch or Planck era, and that started from t equals 0, so time equals 0 to time equals 10 to the minus 43 seconds, which is basically 1 divided by 1 with 43 zeros behind it. And at that point, it was just this singularity, an ultra dense, ultra hot little pinpoint, if you will, of a ball of hot energy where all known physics, big or small, break down, and we don't know. We have no visibility on that time. We cannot see that time. We do not know that time. And we have theoretical physicists working on those properties, and then we have quantum physicists, at CERN and other places trying to clash particles together in like the large hadron collider, and they're trying to piece together some of these things, in particle physics. But that's what we had then. Shortly thereafter, you've got all four forces in the universe all combined, right, into one force. First, gravity breaks off and becomes its own force. And then there's the grand unified theory where there's the three other forces that remain, and then those forces break apart. So first the nuclear strong force, then the nuclear weak nuclear force, and electromagnetism. And so at that point, you start to see a universe somewhat more similar. At least it has some of the the qualities of the universe that we have today with the four fundamental
what,
forces. And that's when matter starts to be created. So first you create quarks and leptons, the most famous of which is the electron, and neutrons and protons are made of quarks. So you don't even have neutrons and protons yet. You have quarks, and then you have this seething ball of plasma energy in the form of photons or light just bouncing everywhere. And so I like to describe it as like I don't know, there's a lot of ways you can describe it, but it's like they're all playing bumper cars, and it's like, being on a bumper car, arena where there's so many cars that no car can actually move forward or anywhere and actually get anywhere. Or I used to live in Tokyo actually for a while, and we used to joke getting on the trains, you'd be packed in the trains like sushi. So the Japanese term's like sushizume. So the guys on the outside of the train you into the trains and pack you in with a bar, and you're standing there, and the train's going and you're just ding 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 ding, but you can't really move anywhere. So this era of the universe looked like that, or that's what we believe it looked like. And then all of these particles are clashing with each other in particle antiparticle pairs, and then there was some slight imbalance, theoretical physicists believe, some slight imbalance where there's a 1 billion to 1 billion and one collisions where one matter particle survives. So all that matter antimatter particles collide, they cancel each other out, and there's one particle out of a billion of matter particles that survive. And the universe continues to expand, it continues to cool. By about 380,000 years, things have cooled now enough where the universe is still a big, basically, ball of plasma. And we get to this point where it cools down enough, about half the temperature of the surface of the sun, to where electrons finally bind with the nuclei that were created of the quarks, right? Which created electrons and protons and neutrons. So the electrons finally bind. You finally have the earliest things, earliest hydrogen, we would call it, and neutral hydrogen in this case. And the photons are let free. So the photons finally get to break free of the electrons, and that's what we now refer to as the cosmic microwave background. So the biggest evidence that we still have, or lines of evidence that we still have, to my knowledge, of the Big Bang are the Hubble constant, where we rewind the clock and we say that, okay, we rewind the clock and everything goes down to this singularity, and the cosmic microwave background, which you guys probably are familiar with, was discovered by a couple of Bell communication techs that thought there may have been some bird poop or something on their antenna, because they kept moving their antenna around, and everywhere they pointed it, they kept finding this radio frequency radiation, wondering where the origin was. But they say that the release of photons in the cosmic microwave background, something like 99.999% of light in the universe. And what's cool about that, when we get back to James Webb, is that James Webb, because it does not have to deal with the atmospheric disturbances of Earth, and because it's tuned to infrared to account for that Doppler shift or that redshift we talked about before, and it stays very cool. It can peer farther than Hubble. And 20 years ago, Hubble, the scientists did the deep space frame, where they pointed Hubble to an area where they thought there were no stars, and they just took, I forget what it was, days or hours or days worth of exposures on that area, and then just kept finding more and more galaxies. And so it's kind of fun because they just kept finding more and more and more galaxies. And I think where the real question lies right now with these early galaxies is that right after the cosmic microwave background, radiation was released, and that's why the temperature of space remains about 3 Kelvin above true zero. It's because of that cosmic microwave background radiation. At that point, that's where, again, like, our knowledge falls apart, right? So we have data, or what we think is data. We're looking at these data, and then we have all of these blind spots, all these things that we can't quite account for. And scientists thought it took a lot longer after the cosmic microwave background, before the formation of fully formed very large galaxies, to form than the 6 candidates and that we're starting to see now.
Well, I got 2 questions right now. One, we should answer Aaron's question quick first. Actually, I will stop. As far as Aaron's question goes, what is a variable star?
Yes, a variable star. Variable star is a type of star where the light will vary over time. So some stars kind of randomly vary in light, and others, like the Cepheids, have pretty consistent patterns of that light varying.
Yeah, I wasn't sure if that was this is an area where I have a massive interest, but for everyone listening and for the future of those listening, if you ever want to say the word amateur, I think you can leave that out now. And you should just, aren't we all self-taught? And the reality is, what was Galileo's, or what was the degree for like early astronomy? What was that degree?
Peeping Tom.
Peeping Tom?
Yeah.
That's right.
Curiosity.
You know, they were talking about that on Joe Rogan with the concept of it didn't take them very long from the time they discovered how you could put dual lenses in it and really see into the sky, where it's like, hey, if you point it this way, you guys have so many more warnings for incoming ships to the harbor, and boom, you have a military relationship with like, we need those. And so suddenly, you got Galileo funding his via military sales of early telescope weaponry to stare into the sky, all because he was selling weaponized telescopes. It took him 5 minutes to do that.
Yeah, I think there was, Neil deGrasse Tyson did a book on that or something, like Accessory to War, but basically said,
Yeah, he was on Joe Rogan. That was who he was just talking about it. Yes. What was the name of the book?
The better your ability to, see things, optics,
Yeah.
and the better your ability to, launch something and hit something, the better your ability to wage war.
What was the name of that book?
I think it's called Accessory to War. I have it up on the shelf. I was a Neil
I know
deGrasse
he was just on Joe Rogan, and I don't usually catch it, but this time I'm like, man, this whole thing is like listening to all of us talk. It was great.
No,
Jim, look, here's my metaphysical question about the Big Bang Theory. It's my problem with theories, all of them, is that they relate to them as doctrine and fact rather than exploring other possibilities, right? So let's say we wipe off the original theory in quantum mechanics as we know it, and Planck and everybody in the early 20s, and as we're looking at this and go, what are the chances that from our perspective, looking out in our field of view and what's coming past us and moving forward, how one of the people listening was asking, like, isn't everything moving away at different speeds? But one of the questions I have is, how possible is it that in an infinite universe, we're only seeing, how scary would it be that the point we're looking back at, how possible is it that the point we're looking back at is the last visual point that we at this end of the galaxy, or at our end of our solar system, of our galaxy, can see from, if we were back at that point, would we actually see a never-ending universe in the other direction? Is it more?
Yeah.
So, you know what I'm saying?
Right. So these are all good points. And, if I'm picking up what you're asking correctly, like, physicists believe that if you were in human terms, the way we think, the far end of the galaxy, and you were looking out, they believe that, like the universe looks, sorry, I said galaxy, universe. They say that they believe it would look the same to them as it does us. They would look out in every direction, and again, to them, from their perspective, it would look like they are at the center of everything.
Yeah, like, well, if all of the galaxies and everything we say of the known universe, like, I love the YouTube videos, or the videos where you got, this was our view of the universe, now this is our view of the universe, now this is the known universe, and it's like, that's a lot of universe, right? And that's great, but what if all of that perspective and us, and no matter how much more we see of it, we zero back to what really isn't a Big Bang, but a point of visual origin, where if we were that far back with everything we can see, if we were all that far back, would we actually see everything we see now, but the other side of what's expanding away from that point?
Well, I mean,
it's a good question.
The sky would be different. I mean, the stars, we would not have the Milky Way. We would not have the Big Dipper. We would not have the the Astronomer,
right?
That one. It would be a totally different neighborhood.
Right. And would that be possible, though, that we're only viewing it from one direction? So we're being thrown this way, and if somebody was thrown from the opposite direction, and the point of that departure had X amount of planets and universes or galaxies around it and everything else, we're just on one side of the yin or the yang of what could be an infinite expansion, and we're not actually looking at a beginning. We're looking at the last point, which is really the earliest point of the direction of where everything else went in the infinite directions behind it that we can't even see yet. But if we could see further, would we not? I don't think that, okay, just coming to me, that those two early galaxies, they're not early galaxies as in they shouldn't be there because of the theory. I think it's our first chance to see that the other side of the twin, the Siamese expansion of all, that we're so far away from where we were when we could have seen all that other stuff. In fact, we've been expanding for so long. All we know is that that's the last place we could get to in our known visual history to see the rest of everything that went the other way from that point. So there's just as much as we're seeing on this side, and there's just as much on the other side of that big, the theoretical point of origin that's expanding the other direction, but we don't have a telescope powerful enough to see it.
Well, we may with the giant Magellan will look back, and there's some speculation I heard recently that there's some people think that there was no Big Bang, and we're just a continuation of the last universe that imploded, and it became us. And this has been an ongoing event for the last trillion years, or however long.
Like a daisy chain.
And Jim's got a good point, right? Because like I said, even in that Planck era, right? Like all physics as we know it break down. So everything at that point is theoretical, and people ask about that. It's like, and I don't have a satisfying answer for myself or anybody else.
No, but am I whack? Yeah, but Dakota, feel free to tell me. Am I totally whack? Is that a totally nuts idea that I'm thinking of?
No. I mean, if the way I'll kind of explain the way I'm interpreting it, right?
He's from Minnesota.
The way we know that
so
the Big Bang.
You have to give him a break. He's from Minnesota, so you have to speak slowly.
Oh no.
Said the other Minnesota.
Jim brought up a good point, right? Because what happened before time began? I mean, that's what we're asking, right? What happened before time as we know it began? And Jim mentioned the theory of like this ever, expansion, collapse, this maybe pattern that goes on forever. The fact is that could be reality. We don't know. Even theoretical physicists talk about, a multiverse, right? And our universe could be one bubble, so to speak, within a sea of bubbles of universes in a multiverse, right? And that's.
Yeah, and what's we could be dangling from a little thing on some cat's collar also.
Yeah, I always think it might be like Orion's belt in the galaxy.
Yeah. I mean, when you look down at the atomic level, those are really solar systems when you sort of look at it, depending on the element. You have the central core, which would be like our sun, and yet the electrons going around it, or protons, would be equivalent to the planets. So we may be in a drop of water on some swamp in some other parallel universe. I mean, and we don't know, right? And we don't know. We have, I mean, just before I left being a docent, we had a gathering of all the astronomers, technicians, and docents at Kitt Peak, and we had a pizza party. And the reason for it is one of the key people in the National Science Foundation just returned from a worldwide conference on exoplanets. And he was speaking on the exoplanets. And when he came, he said, based on all the information they've gathered from all the astronomers looking for exoplanets, that they calculate using proven mathematical formulas, at least they've worked in the past, that for every star in the universe, there's 1.5 planets. And out of that incredible number, there are 2 billion, that's with a B, 2 billion Earth-like planets orbiting a similar sized brown dwarf star like our sun in the inhabitable zone with liquid water. And to quote Jodie Foster's character in the movie Contact, if we're the only ones, what a waste of space. So, I mean, that was one of the most incredible things. I mean, our 2.1 meter up at, say ours, the 2.1 meter up at Kitt Peak that Caltech used for 5 years. They used adaptive optics, and they did remote viewing from Pasadena. And they sent up, when they were going to observe, they sent up a UV laser, and at 18,000 feet, it had to be a specific diameter of the beam. And the mirror that goes into the spectrograph actually deforms 1,200 times a second. And they said that the quality of imagery coming from the 2.1 meter that Caltech used was comparable to that of Hubble. And they were, over the 5-year period, they were able to catalog 8,000 exoplanets in a postage stamp size area of our Milky Way. I mean, not even outside of our galaxy, within our galaxy.
Yeah.
And so that sort of answers the question. We're not alone. We can't be. The odds are, with that many billions or trillions or however many zeros you have behind it, number of planets, we can't be the only ones. We can't be the only flukes of nature.
Have you gone looking for the exoplanets, Dakota?
We haven't seen any with ours, but it's a really fun thing. I mean, it's clear that many of, and we talked about this a little bit when you were on site. It's clear that many of the stars in the galaxy, and arguably other galaxies as well, are binary stars. So the stars themselves are pairs orbiting each other. And then as Jim mentioned, I mean, I don't think we've actually looked up at any star and definitively said that star doesn't have planets.
Yeah.
So, to our knowledge, every star pretty much has planets, because the way a star forms is in this, accretion disk, right? So you can almost imagine this like frisbee of, this disk of material just spinning, and it's this accretion disk that's just spinning and spinning and spinning, and then all of that material kind of coalesces obviously in the center into a star, and that in the disk around it, the planets of that star ultimately gobble up all of that material.
Mm-hmm.
So I'm going to say something right now for everyone listening, and for everyone in the chat, and for future listeners. This, I know I'm going to go here, and this is one of the hardest things about writing a book and getting it out. And you got people at different introductions to all this information. And I'm about to say a very baity thing. It's not Atlantis, but it is Atlantis of the stars. But I am going to put a decent question to it, I hope, which is, there has been so much debate about anywhere that there is a planet that can, a system that can contain planetary life like ours. It's always said that it's a binary star system, right? And then there are so many people who get hooked on the Nibiru, Mysterious Planet 9. But
yeah,
so two things that I'm going to ask, again, for those who are perking their ears up, who are out there for it, where is it? And then at the other point, though, because I've talked to people, there's a gentleman I spoke with who lost his mind when I asked him. He said, I've seen it with my naked eye by the sun. And I'm like, oh, when'd you see it? Because, it's not a magic thing. If you can give me date, time of day, and where you were on the planet and what you were looking at, I think we could take a picture, right? But so the questions are these. One is, why is it so hard to determine for sure whether or not we are in a binary star system? And two, also then, how hard would it be to locate whether it's Planet 9 or how do we not know? I've given answers for it, but
There should be
Yeah.
planet 10 because Pluto's still a planet. I don't care what they say.
Bitch.
It's,
Yeah.
it's big,
I'm with Jim on this one.
it's bigger than Mercury, isn't it?
Yeah, I just go with Rick and Morty. You know, it's like, you know, Jerry says Pluto's a planet, bitch. Yeah.
Well, there's a joke that there's actually a joke that, like, you know, it was an astronomer society that demoted Pluto, but not specifically planetary scientists. And I heard this, I saw that read this article that there was a NASA planetary scientist that said, "Oh wait, hey, wait a minute, we didn't demote Pluto." Because by definition, it has its own orbit, it has its own moon, and it also has cleared out the space around it. Because by the definition of a planet has to clear out its space, well, what are meteor showers we see every few times a year? I mean, by that definition, even Earth hasn't cleared out its pathway.
Yeah. But yeah, what do we do? What do we do with, like, okay, and I think a lot of people don't distinguish that we're not taking. There's telephoto lens photography with a picture like everyone conceives of it. I don't think a lot of people understand how infrared wave frequency, you know, the radiology of, you know, you see an artist, people don't get it when international news says, you know, we found this and that, and then there's an artist interpretation photo, and that what was really sent back to Earth was a bunch of radio lines. But at the same time, is it possible that we have a binary star system? Is that even a thing, really?
You know, well, a binary system's absolutely a thing. We actually, if you come to our observatory, we'll show you a lot of binary stars.
But not ours.
No, yeah, and that's a thing. So I personally,
There's no math for that.
it would be hard for me to believe that we're in a binary star system, okay? Because, like, I would think we should be able to look out, and if there's actually another star. So you think about it, like, I think Jupiter's one. I'm gonna be a little off on this, but Jupiter's like 1/80th the size of the sun or something. But Jupiter needs to be, you know, several times, you know, bigger than it is to be a star, right? And we can see Jupiter quite clearly, right? Like, I can go out tonight, and if it's clear, I will see Jupiter. And so you can see Jupiter, and a star needs to be many times larger than that to actually be a star. So arguably we should be able to see another star if we are in a binary star system. Now, there are caveats to this, or you know, there are you know, there's nuances, right? I think it's called the Schultz star, but you know, there was a star that did a close flyby of our solar system, I believe 70,000 years ago, right? And we have reasons to believe that there's been other close flybys as well.
Yeah, but this is the one you wanted to talk about.
Our solar system may have picked up some of the debris from that system, and we may have shared some debris with that system, which opens a whole new, you know, Pandora's box of questions.
But isn't that the Schultz? The Schultz is the one you told me to look into, right?
Mm-hmm.
Yeah, but I think you should expand on, like, it has planets around it, or no?
Pardon me?
The Schultz does or doesn't have planets around it. Does that have its own system?
That's a good question. I have not actually looked at that. My presumption would be it'd be likely that it would, because most stars do or did, you know, at some time.
So we could be dealing with some sort of multiple solar system / local neighborhood galactic bacterial / planetary spread. I mean, things could be passing close enough for, like,
there could have been some material exchanged for sure.
Galactic syphilis.
Yeah, I mean, the thing about space that a lot of people don't take in consideration. You go to the movies, and there's a space-related movie. They're trying to make it as accurate as possible, and they're going through the asteroid belt, and all these rocks and stuff all over the place. The average distance between objects in the asteroid belt is over 650,000 miles. So if
you're taking all the fun out of it.
Yeah, so if you were to hit something going through the asteroid belt, either you're incredibly lucky, or you're not, your navigator really hated your guts and he wanted you to go splat. So
there's no real running into stuff. But if you were in an orbit, an elliptical weird orbit. Okay, not putting you on the spot for this one, but one of the things I theorized was let's just say we had a more advanced human society prior to now. And if we did, what would it take for a self-powered, solar-powered, maybe scientists? I don't know if you knew this one, Dakota, but they have a programmable brick building system that actually is a bacteria that grows into bricks, the shape and the size and the structure you want the bricks to grow into. So how hard with flash drives and whatever else for a more ancient advanced society to take a satellite and say, well, let's put it on an elliptical orbit that's looping out 2 planets or 4 planets or 8 planets, or so it's only passing within a data distance. And so if you had a daisy chain of satellites that were on loopy orbits that exceeded the solar system for you to take photos, I mean, how far would you be able to see that?
Yeah, it's, again, great questions, right? I mean,
not to make you prove
we can see quite far, and it'd be a question of how far, you could actually make it, right? And I think, some of our biggest limitations are the actual expansion of the universe, right? Because they say, Matt, you cannot, it's the whole E equals MC squared thing, right? We cannot, matter cannot meet or exceed the speed of light, right? But Einstein's theory does not say that space itself cannot expand faster than the speed of light. And what we find, what the evidence that we're seeing now is that the universe is expanding faster than the speed of light. So we actually figure that the farthest, so including the 6 candidates that they found that are, theoretically, as we thought, too early, too big, too grand to be where they were, right? And of course, Jim mentioned this, but they're going to do spectral analyses of these things because they still need to be confirmed that they're at the distances we think they are, and that they are the masses that we think they are, and that they are of the materials that we think they are. But a lot of that can be figured out through the spectral analysis. But we are finding ourselves in a really challenging spot where, as the universe continues to expand, there's going to be a limit to what we can see. And like you mentioned, what's beyond that? Well, there's stars and things that we can see, and that's why we're kind of up against the clock, so to speak, to see what we can as in the deep past as we can, because as the universe continues to expand faster than the speed of light, objects that are visible to us now in the future will be invisible to us and pass beyond that veil of or shroud of visibility. And so that's the question. Like if an advanced civilization eons ago sent things out, is there maybe a little more that they could see? I think their biggest advantage, honestly, would be the fact that they were looking way back then, because everything would have been just that much closer together, right?
Yeah.
Because they would still be up against the physical limitations of the expansion of space, right?
So no matter what the limit, so that means 70,000 years ago, it would be significant if we crossed paths with another planet, right?
Yep.
Or another star. If they're pretty adjacent to us, that could be. What else was adjacent to us when the Schultz star happened?
Yeah, it's a great question. I should do some more research on that.
Next show. Let's bait that down. Do the research. He doesn't know, folks. I don't know. But we're going to figure out, because when I was writing my book, Jim, I haven't done this in forever. I am going to digress. So in my research, I was going to write a book for 9 months, not 3.5 years. And when I was doing it, something I haven't talked about really a lot at all on any show ever in a couple of years, I've never talked about this, is that I got a galactic and universal maps. So I looked at the galaxy, I looked at our galaxy, I looked at the spiral, I looked at where we were, and I kept trying to find timelines that showed where our planet was in reference to the galactic spiral, in reference to dates and times that lined up with massive catastrophic events on this planet, to try to dial. We have this massive supervolcano that goes off 75,000 years ago plus or minus, they say 1,000, but 5,000 wouldn't be much off. So what if we have a planetary system that's not doing, they're not getting along very well, and then on top of it, we come, what would be what I was looking for in my research was, were we ever close enough to a habitable planet that was outside of our known mind's eye? And would that society, if it wasn't human or was human or co-human, was there ever a point where we galactically crossed in the spiral where it would have been reasonable to leave one planet to go to another planet that's everything's on its outward travel, right? As it's spiraling. And I was looking at that and going, oh my gosh, was there, and I just stopped, because you can't do everything in 3.5 years. It's shocking. Apparently you need more.
I think that's a fun premise for a book.
That's exactly why I was writing about it.
To go back with Einstein theorized that we couldn't exceed the speed of light. What happens if there are stars going away from us in excess of the speed of light? We don't know they're there.
Well, I'll rely on Tesla's
because of the stretching of space-time, right?
Right. Unless they're leaving some debris on the way that we can pick up.
Yeah, but the light,
something's expanding faster than the speed of light, then we have no way of detecting it.
Yeah. Well, and a fun thing is, and I know, Jared, you're kind of interested in these things, but geometry is a beautiful thing, right? And so you might
unless you're trying to get an A in it, but go on.
No, but I mean, just the study of shapes and the way things are, the reason why the way things are the way they are shaped, right? So I mean, if you look at the funny thing is, if you look at the ancients, and they kept looking up, and they kept they saw the moon, they saw the sun, they saw planets. Then ultimately, like you mentioned earlier, Galileo discovered the Galilean moons on Jupiter in the early 1600s, right? And it's like, wait a minute, those are little pinpoints of light that look like they're spherical as well. And it's like, that's just the way physics works, right? The way that you get the highest amount of mass in the smallest amount of area is a circle. It's a sphere.
Yep.
So, it was funny when everybody's looking out. It's like, oh, well, that's spherical, that's spherical, that's spherical. And then like, oh, but we're not. We're on this flat thing.
Yeah.
And the funny thing is, like, that's just the way nature works. Nature works that, it in a way that it really likes spheres. It's the greatest way to the most amount of area in the smallest area. And so I mean, if you ever see like a cereal box that's spherical, that's probably the box you want to buy, because you're going to get the most bang for your buck. But
if they fill it and it's not all air in a puff bag.
Yeah, exactly. Yeah. As long as it's filled. And then on that point, there's a shape called a logarithmic spiral that actually follows like the Fibonacci sequence, the golden, what do they call that? The golden ratio.
Golden mean, golden. There's so many goldens. It's very golden.
Yeah. And like, you think of like the shape of a hurricane, right? The shape of a hurricane is a logarithmic spiral. The shape of a spiral galaxy is a logarithmic spiral. And it's kind of fun. I mean, when you look at that and think about that, it's like you see the videos on the TV of hurricanes rotating, and so like, even without seeing it, every galaxy we take a picture of, it's this static picture, but just from its shape, it's moving. And if I'm not mistaken, like one galactic, we talk about 1 year of of our Earth orbiting the sun is 365 Earth days, and one galactic year is something like 235 thousand years. Like, it's almost a quarter of million years. So like a quarter of a billion years is a galactic year. And so it's kind of fun when you talk about that, right? Like, Schultz stars in our neighborhood, it just has this flyby. And in the meantime, we're in the Orion Spur, the Sagittarius arm of the Milky Way, like kind of out in the suburbs of the Milky Way, and we continue to orbit. And as we orbit around the center of our galaxy's moving in our local galactic group and moving towards Andromeda, and we're going to eventually coalesce. And
when do we get Andromeda? Keep going.
Go ahead.
No, keep going, because I was going to say, when are we going to hit Andromeda? Everyone's worried about when the Earth, the sun's going to go supernova in like what, 4.5, 5 billion years?
No, it's
Yeah,
too
4.5
small.
billion.
There's not enough mass, according to the astronomers at Kitt Peak. The Earth, the sun would have to have at least 8 times the mass to become a.
Yeah, you're hearing the echo.
Yeah.
I don't know.
So,
it might be someone's
I think
monitors.
the collision is, I'm just looking it up, but the Andromeda Milky Way collision is predicted in 4.5 billion years. So I think that's somewhere around the time they believe that our sun might die out. But
wait, so Jim, will our sun die or whatever, Dakota? So our sun is not going to fizzle out?
No, the sun's going to fizzle out. It'll burn out all its energy and it'll start growing. And it'll eventually encompass, but it's not going to blow up. It's not going to be.
When does it burn out Earth? When does it burn us out?
About 2.5 billion years or something like that.
Is it, Dakota? Is it sooner?
with the sun?
Yeah.
Yeah. No. When does Earth burn out, and then when does our solar system hit Andromeda? So if anyone's worried about the planet,
so 4.5 billion years is the collision, as they call it, between Milky Way and Andromeda. And when they talk about this, it's not really going to be a collision where things, it's going to be these flyby things. Like, you're going to see. It'd be a pretty cool time to live, where you see a bunch of stars flying.
We're not going to get hit.
Yeah. But I like, it's kind of like Jim said, flying through the asteroid belt. Like things will still, to our perspective, be pretty far away. So there's not like a huge likelihood that I think it's going to be like this life-ending thing in either one of the galaxies. And then let me look up the sun.
Yeah, I thought it was 4.5 for the sun to like burn up Earth. I thought that was 4.5, not 2.5 billion years.
Yeah, so they're saying about 5 billion for the sun. So the sun's going to fizzle out in about 5 billion, and the Andromeda Milky Way thing's going to happen in about 4.5. And I mean, this is fun, and it goes kind of to Elon Musk and all the other things, and physicists will agree. They say, hey, we need other ways to survive beyond just Earth if humanity is going to survive, and if other advanced civilizations are or were going to survive.
Well, I don't think anyone really appreciates the fact that we are on a planet with an expiration date. It's not going to survive the sun burning us to a sizzle. It's just, we could live in bunkers, I guess, right? No, too hot. We're going to be in an easy bake oven.
Yeah.
That's going to be one big light bulb.
Yeah.
Not to freak anyone out, but just everybody should take this into account. The Earth has an expiration date. It's not a maybe. It's not going to get saved. The Earth will be gone, and humanity needs to be somewhere else. And obviously, how many great grandchildren we need to worry about this? But we don't.
Hey, but you figure where we have come in the last 120 years, and we keep inventing things faster and faster. So the time frame between not having a yellow widget and having a yellow widget being invented or created, that keeps that time frame keeps getting smaller and smaller and smaller. I'm blessed to have Ben Rich, who is the president of Lockheed Skunk Works. He replaced Kelly Johnson. And Ben and I talked once a quarter for 25 years. And just before he died, just before he passed away, I think it was in 96, I called him at USC Medical Center in LA. He was dying of esophageal cancer. And he told me, he said, Jim, we have things out in the desert. And he wasn't referring to Area 51 either. He said, we have things out in the desert that's 50 years beyond what you can comprehend. Not what you think you can build in 50 years, but what you can comprehend. And if you've seen movies like Star Trek or Star Wars, we've been there, done that, or decided it wasn't worth the effort. And at UCLA, he gave a talk, and in his prepared talk, he said, we have the ability to take ET home. Think about that statement. We have the ability today to take ET home, but our government will not allow us to release that information.
Well, I like what you said, Jim, about they said, well, then he say, look, Jim, we're ahead of anything you can imagine.
I mean, I mean, 50 years beyond what you can envision, what you can, theoretically make in 50 years, not what you think you can build in 50 years. And Ernst Energy says, why did they destroy all the technology that brought us to the moon? Because David truly did not want, he wanted the shuttles to survive and the Saturn V program to die. That was too good of a backup if all of a sudden we started losing space shuttles. And we lost two of them, not because of technology, but because of human carelessness. They went to the green coating on the external tank, and they had a waiver for it, but they wanted to use green foam, and that green foam broke off on liftoff, and it took out the leading edge of Columbia.
Oh, that sucks.
Challenger was lost because they didn't listen to some young engineers saying the specification said if you have more than an hour and a half or 2 hours below 31 degrees, you cannot launch until you've been at a certain temperature for X number of hours or minutes.
Yeah, those engines were built actually out here in the desert, not far from my hometown.
Was it Moab?
No, it's up in northern Utah by Promontory Point, outside of Ogden. It was ATK.
Yeah,
and it's important to remember that shuttle mission had been actually this is funny. This is going down some rabbit holes that some friends were pushing me on so hard the other day. Because there's these posts out there where like, look at this, look at this, look alike. That person's alive, that person's alive. I'm like, look, the government's pretty good at letting people die if they want them to die, to not leave loose ends out there.
Yeah. Yeah.
And no, anyway, with that particular shuttle mission had been delayed by weather several times, and the teacher was going up on that mission, and so it was a really bad PR mistake. It was groupthink. It's I was in communication school, and that was a classic faux pas with groupthink, where they had delayed so many times. They were losing the excitement of the public, and they said, we got to do it now or it's not going to happen. And so they, against the wisdom or the strong
all the safety protocols were thrown out the door. Out the window.
They threw them all out the door, and all the engineers at ATK were saying, don't launch with these O-rings are going to give out. And on Aaron's question, it's a good question, because it is a head scratcher, and you start scratching your eyebrow on that one and wondering. But I actually had a friend, like the friend that I mentioned earlier, work on the shuttle missions, and he said, Dakota, there's a couple things here. He said, one, realize, and I think the last stat I saw was like NASA's budget's something like $4 billion a year. Like, go look at the national budgets and the DoD budget and this and that. Like, NASA's budget's actually incredibly small. Much smaller than some would like it to be. And like you said, they wanted the shuttle. The public was done with the shuttle missions because they thought, well, that's great. We've been to the moon, been there, done that, and we want to get this shuttle program going. And I don't think the public fully appreciated the fact how difficult it would be to get back to the moon, after moving away from those programs. And we had warehouses, like tens of thousands, hundreds of thousands of square feet of warehouses, just stacked with all of the plans to these missions. You have to realize there were somewhere to the tune of 400,000 different contractors, people working on these missions. And you think about the piles and piles and piles of plans and everything that it would be to create those Saturn V rockets. And eventually they said, you know what, it isn't worth our time to pay the heat, lights, gas, and keep all of this stuff around. So they sent teams out to try to find the best, the most helpful of the plans and the most crucial of plans they could. But then they ultimately said, hey, if we built a rocket now, we wouldn't even build it the same way we did then. So it's just, we can't afford with our limited budgets to hold on to all these plans. So we'll keep what we can, the best of the best, and do away with the rest.
They should take NASA out of the launching capabilities. Turn it over. Look what Elon's done. I mean, it took him, was it 6 years or 8 years to do the first 50 launches, and it only took 2 years to hit the next 100.
Yeah.
And how many Falcon 9s has he launched this calendar year so far? And we're only in the middle of March.
Yeah, and the fact they're landing them now. I mean, it's pretty amazing, and that's what's fun about the privatization of some of these things.
And I had a chance to tour SpaceX on February 22nd. I had an invite from Elon Musk personally. I sent him my Blackbird book when his son was born. My favorite airplane is the A-12 Blackbird. I had one in Minneapolis for 15 years. That was my baby.
We have one out at Hill Air Force Base. I remember
I helped take that one apart. It's the SR-71C.
Did you really?
Yep.
Wow.
Yeah.
I've loved that since I was a little kid. My great grandfather was a pilot in World War II, and he'd take me out to the Hill Air Force Base Museum, and there's nothing like seeing that SR-71.
You took that one apart, Jim?
I helped them take it apart. It was August of 90.
To bring it to the museum?
Yeah, they were taking it apart. I have pictures. There's one of the docents. He's a retired sergeant major. I think his first name is Kay, K-A-Y, and super guy. And I told him, I said, well, I helped take that apart. And you can see him. Yeah, sure. You helped take that one apart. So I went out in my car and got my Blackbird book, brought it in, opened it up to 981, and it shows the fact that I have pictures of it being taken apart.
It's good proof of evidence.
Yeah, and they actually moved theirs by C5 before I moved mine by C5. We cut the wings off of our A12, and I have a picture of it here somewhere. And
Jim's responsible for moving more than one Blackbird to different museums and disassembling it in the most epic way. There it is, getting packed.
There it is. Very cool. And I have the distinction of being the only person on Earth that had been in a cockpit of a Blackbird at 33,000 feet at Mach 0.72 inside a C5.
Now Jim does need to expand on that because it's pretty cool.
That's awesome. Did it look pretty dark in there?
No, the lights were on.
All right.
I mean, we only had 1.5 inches of clearance when we rolled that puppy in there. And I had measured it every which way, and I knew it was going to fit. And if it was a landing gear that was going to be the problem. We had to take the outer wheels and brake assembly off, and that's where we had the 1.5 inches, actually 3/4 inch. It was 1.5 inches total. But if we had a problem, we could have put a come along in between it and torqued those in and moved it back, moved it in. But we didn't have to do that. But it was I told Ben Rich that right after we landed in Minneapolis, and he just laughed. He said, I'm very tempted. I should issue you a Mach 3 card, Mach 3 plus card. But I also landed it. So and no one can do it. I was 18 when I saw my first Blackbird. I'm 78 in 10 days. So it's been a long time since I saw my first Blackbird. And actually,
you saw it on base, Jim. Yeah. You should tell Dakota how you saw your first one.
I was sent from Lowry Air Force Base in Denver, and this is February of '64, a long time ago, probably before your parents were born. And
I think my mother was born in '64.
Okay. So I got a set of orders to go to Edwards Air Force Base to support 3 programs for Category 1 testing. I was a telemetry guy. And it was the YC-141 Starlifter, the XB-70 Valkyrie, and why am I getting an echo?
It's just happening every now and then. I don't know what it is, Jim.
And a classified program, which turned out to be the Blackbird. And I had a bunch of overtime put in, and it was March 10th, 1964. I was taking the Northrop shuttle using a Piaggio, and it was flying between Edwards and Hawthorne, California, LA. And I hear this roar, and I went running down the flight line to see what it was. I'm looking at the XB-70 test pad. And there at the test pad, I thought at first was the X-15. It was black and long and pointy fire coming out the back. Then I realized the people were too small. So all of a sudden they said, hey, we're loading. So we went back, jumped in the Piaggio. We took off over Rogers Dry Lake. And to say this is the Blackbird, we came and banked right over. And I looked down on top of it, and I've never been the same. It affected me so dramatically. I mean, it's just unbelievable. And so cool. the rest is history. And what's really comical, if the official policy with the Blackbird program was not to cooperate when someone asked questions. So I started in 1968. I sent Air Force, Lockheed, CIA, Department of Defense a letter saying I would like to purchase 10 color 8x10 glossies of the Blackbird in the air. There was nothing restrictive on that back then. And their official policy was not to cooperate. So I started digging. The more I dug, the more I found out. The more I found out, the deeper I dug. And over the course of the last 60 years, from a historical point of view, I've become one of the most knowledgeable people on the planet on the Blackbird program from its conception to its death. And
including every pilot that's ever flown one, right?
No, every pilot that's still alive that crashed one. And I've met most of the original. I met almost all the original pilots. Both the agency pilots that were on they were on leave from the Air Force, and then the Lockheed test pilots, and then the operational pilots. So I did that before there was an internet. So you actually had to get in an airplane or get in your car and drive to their location and interview them. And it's just been a lot of fun. I mean, it's something that I never in my life did I ever think I'd be a published author. I have 29 books in print. One of them hasn't, it's at my publisher as we speak. And
very cool.
Jim talked his way onto nuclear submarines, Dakota.
Yeah, I have photographed every type of operational nuclear sub the United States Navy has.
Wow. And
it took me 7.5 years to get on one of the 3 Seawolf boats. And I got a friend of mine who was on the Seawolf. I got on the Connecticut. And he said, they let you on that sub with a camera? And I said, yeah. And they let me photograph everything from the reactor bulkhead forward. Reactor bulkhead behind, you're not going to go. I don't care who you are. They showed me the tunnel going by the reactor back to the maneuvering room. It's painted gloss white. When you look in it, you can look in it, but if I stuck my head inside of it, they would arrest me. So I'm the only reason I have one book that's not finished, and it is my book, my third volume. I have 3-volume set of nuclear-powered submarines for the United States Navy. Volume 1 was the Los Angeles class 6088 and the 6088Is. Those are the I boats, they call them. And then also, and that volume also had Know Your Adversary. So I have the Russians, the Chinese, the North Koreans, and the Iranians subs. And then volume 2 was Seawolf Virginia class, and I also covered the NR1, And volume 3, which is not done yet, I have the C4 and the D5 boats completed. Those are the nuclear tip, the submarine launched ballistic missile ones. I don't have the Arsenal boat, the SSGNs covered, and those use tactical weapons versus nukes. So I'm just waiting. There's only 4 SSGNs. The USS Michigan is forward deployed to Guam. It carries 154 Tomahawk cruise missiles. So they sort of gone on the surface in between the Straits of Formosa, just let the Chinese know that we have a non-nuclear deterrent waiting for you. Plus, if they decide to put the Connecticut or the Seawolf out there, also the Seawolf Virginia class subs, this is in the Seawolf class, not Virginia. Seawolf class submarines have a 2-story torpedo room. They have 8 torpedo tubes. And when they go on patrol, they carry 50 Mark 48 torpedoes. And one Seawolf class submarine was designed to take out the entire the Soviet Northern Fleet. So it's a pretty, and the test depth, they say, well, it's above 800 feet. Well, it's below 2,000 feet. So,
Jim.
Right.
Well, sorry, finish that one up. I got a question for you. Dakota's got to hear this.
No, I'm done.
No, well, all right. So Dakota, I had asked Jim just the other day for the first time. So a listener had asked, what was the weirdest thing that somebody had? I think this really relates to, it's like, we know all this thing, what's going on in space, and we don't know what's underwater. And to that point, one of the listeners said, hey, what's the weirdest thing Jim heard about that had happened underwater to a submarine? This is now Jim's turn to tell you.
Mm-hmm.
Well, a friend of mine was on the USS Hampton, it's SSN 767. They're at about 600 feet. They're going at 30 knots. And all of a sudden, the XO tells my friend, there's something coming up on us. And something went by the Hampton at over 700 miles an hour underwater. And they don't know what the hell it was. It just blew them away. Another event with the same person, they were in a severe thunderstorm. Rain was coming down like someone opened up a fire hydrant. And he went to the bow of the ship, and it was dry and rain everywhere. And he looked up, and there was a disc right above the ship. And this guy's not a dingbat. He has a PhD, I think, from MIT. I think he has a couple of them. So anybody has a PhD is a little bit on the weird side anyway. But you don't have a PhD, do you? I hope not.
I'm a ski bum from Utah, man.
But 700 plus miles an hour underwater.
Yeah,
something
amazing.
Went by. Something went by, and they picked it up on sensors.
Amazing. Yeah. And you guys, I'm sure you have talked about it, but it reminds me of some of the crazy footage of things that pilots have captured. And, I think that the takeaway is there's still a lot we don't know.
In the mid 1950s, my boss at the time, he retired as a major general, but Wayne Gatlin was a young major. He's on alert at Duluth Air Force Base. They're flying F-94Cs, shooting stars, and they get the klaxons go off. There's a fast-moving unknown over Lake Superior. They take off. They're being vectored out of the Finley Air Force Station, which is right on the north shore of Lake Superior, and they're out there, trying to find this thing, and they. Finley says it's directly to your west, about 12 or 15 miles, and General Gatlin said they saw it, and he put the thing in afterburner, which you can only do for about 60 seconds, and then you're out of gas. And every time they try to lock on, the radar would die. As soon as they got a confirmed lock on, it would just die.
Wow.
And as we're heading towards Finley, Finley says that the object is coming towards us at an incredible rate of speed. We lost it. It's not there anymore. And General Gatlin's going as fast as he can. And he said, well, they're getting close enough so they can see, they can see the shore. And he said, well, the reason why you can't, you're not picking the thing up on radar, it's directly above you. It was hovering there. The guys went outside and this thing shot straight up.
Wow.
So I asked General Gatlin, because I was on state staff with him, the Minnesota Air Guard. And I said, General Gatlin, let's say I'm a F-4 pilot and I encounter a UFO. What should I do? He said, when you land, go through your post-flight debrief, go to the O Club, get 2 or 3 stiff ones down them, then go back to your billeting and forget what you saw. Because trust me, it's not going to enhance your career at all. You come out and say, I chased a UFO. That's different today, though. That part has changed dramatically.
Yeah.
Well, Dakota, I don't know how much more time you have. I wanted, for everyone listening, I did want you to here's a rewind. I wanted Jim to hear. We all have extended family with military history. What are the horrible chances you have time to do a quick recap of how you guys, you have an interesting relative history for World War II and skiing, and how does that bring us maybe up to you talking about the hotel again, or how people can find you, or how much more time do you got?
Well, I actually, my wife just sent me a text. I do have a baby I need to put down, so I'll be real quick. But I will give a little recap. Yeah, I mean, some of my, I have a very interesting, deep history, but some of my history was, I'm in Utah, so some of my family history is literally Mormons coming across the plains with horse and buggy, and some of them were even in the handcart companies. So if you look into that history, it's kind of fascinating. And another part of my family came in to Hill Air Force Base, because of their military careers, which is fascinating. But I had 3 grandparents in World War II, and so I greatly respect, the service of my family members, and which has been fun. And yeah, I mean, again, our hotel, it's supposed to honor the history and heritage of the area, the Little Mountain Valley. The valley that it's in has 3 ski resorts. One was the site of the 2002 Olympic downhill, which is really fun. And we're right nestled in a reservoir there. And we've got the hotel's only 15 rooms. So it's very small. And, for us, it's all about having fun. It's all about getting out. And, part of it to me was you hear all these things online, you hear everything from, every way here to Sunday. And it's part of that is breaking out a telescope, discovering things for yourself, seeing the craters of the moon, seeing the rings of Saturn through a telescope, or seeing the Galilean moons. For me, when I saw the Galilean moons, that was a game changer. And when Galileo Galilei made his discoveries and said, hey, we're not the center of the solar system or the universe, and it's heliocentric, starting to put forth what he did. I mean, the church was not happy.
No, they weren't. No, they weren't.
He was locked in house arrest for the rest of his life, and so I'm all about and even Aristarchus, second century BCE, so over 2,000 years ago, was saying that the Earth was not the center of the universe, and people just thought he was crazy, and then that idea carries on for thousands of years. So the fact is, at least we use science now, and we use methods to verify the facts, and to be able to replicate. That's the nature of science. And so we just like getting people out, viewing things for themselves, making having the discoveries of the Galilean moons that Galileo Galilei did. And so it's a lot of fun, and that's what we're all about.
Well, we really appreciate you coming on. I know you got to get a baby. Do you want to, and Jim and I can talk a little longer and we can let you go, but is there anything else you want people to know about? If they want to stay at the hotel, do you want to give out a website or anything, or are you good?
Yeah, absolutely. It's compassroseLodge.com. all together, compassroselodge.com. That's our website. I think you click on the Adventures tab. Under Adventures, it mentions the observatory. You can see a couple shots of the observatory there. Again, we have public tours most nights of the week. Summer's a good time, winter's a great time. We're going into a slower time right now for visibility through the spring, but anytime's great whenever you can make it. So if you're ever find yourself in northern Utah, please stop by and say hello. We
It's
got the
stunning.
coffee shop too.
Yeah,
So
look,
that's
the
how
coffee
we
shop.
met, and we'd be happy to chat.
Yeah, look,
Yes, sounds great.
Will you come back on sometime publicly
Yeah,
on the
absolutely. Thank you guys.
Yeah.
I really appreciate it. It's great
Dakota,
to
it
get
was
to know
fun.
you guys
It was
better.
It was fun talking to you, and it's quite an accomplishment to build your own observatory. So.
Thanks.
Oh, it's one hell of a
Thanks.
thing, Jim.
Well, the journey's just begun.
Yeah.
Thank you, guys.
You have a
take
good one.
care with your baby, and I'm going to
Appreciate
talk
it.
good things about you after you're gone.
Take care. Bye.
Man, I just want to let everybody know, and Jim, you haven't seen it. I said we were talking about Dakota being on since the discoveries about those early galaxies, but I got to tell you, the hotel that they built is incredibly intentional. It's only 15 rooms, but a couple of those rooms have those very Instagram / Pinterest, the bunk beds that have the cute staircase up the middles with either side. And all the bathrooms have 10-foot tall barn door. Like they roll the barn door to go into the bathrooms, and all the bathrooms have these gorgeous walk-in showers. They nailed it on every level. This is a boutique hotel. It's not overly expensive. It is not too cheap, but for in the valley, it's like you're literally in the valley with, like, did they film Lord of the Rings here? And you're at a water basin in a town. For those that don't know, okay, the hotel itself, besides the observatory, has some outdoor tenting, glamping, lounge areas. And they have a cafe, which he started to mention. I overtalked him, but the cafe is cute as hell and serves, I think, some of the best coffee I've ever had anywhere in any state from, anywhere across the whole country. So the place is great. But the other thing it has on this cute little main street, besides like 5 other little restaurants and bars, is the longest opened bar west of the Mississippi in all of American history. And it's called the Shooting Star, and you can walk to it across the street. So we're really digressing, everyone, because this bar, of all places, Utah, chose to screw prohibition and paid the fines. And the Shooting Star was open through prohibition. It never closed. They just paid the fines. And every square inch of the entire ceiling of this bar is covered in dollar bills. And you got signatures from the 1950s and 40s and 80s and like all the way back. People have been nailing dollar bills with their date and their names on it. And it's just this little one room, big enough, with a pool table, but it's called the Shooting Star, and it's just, I don't know, 200 feet from the hotel where the observatory is. I didn't even get to tell you that he has, for whatever reason, they have more of a hobbyist telescope. I mean, it's huge, and it's sitting on this giant tripod, and it's in the breakfast / hangout where they would do like private brunches or something. But it was owned by Stephen Hawking. It was Stephen Hawking. And I'm like, how do you guys have that? And the military history, one of his grandfathers was on the, when they developed the mountaineers, the skiers in World War II.
Okay.
His grandfather was one of the first. I mean, they came up with it. I mean, it's the family's history. You go into this cute little cafe with about 6 tables, and all the pictures on the wall are their family, and they're very humble. They're very smart. They got one hell of a style sense. And I do design build for a living, but I wish this is not an endorsed podcast, by the way. I just love this place. And when I met Dakota and we got upstairs, and his knowledge base is so deep and broad, and the amount of photos he has of space, of things that he just is experimenting with. That's the thing. It's like he's showing people, and it's worth every minute for people to come. But if he's saying that you can't really see much in spring, then I guess wait for when you really want to do the observatory. But from the standpoint of maybe the Lord of the Rings wasn't filmed here, but the hiking, I'll tell you, the skiing, but is amazing. But Huntsville and Eden, there is some of the most beautiful places I've ever been in the country. So that's all I have to say about that.
I got a quick question. You were going to give me a buzz yesterday, and you didn't. Have you made the changes to the?
We're still on, remember?
Yeah, I know. Have you made the changes to the thing I told you to change?
Oh yeah, we'll have to chat about that. It turns out that it's not labeled that way.
Oh, it's not.
It's pretty clear that you can handle it whenever. You can take whatever. We should just talk about Belize quick, right, for everyone on.
Yeah.
So we are doing an expedition to Belize. We are going to be doing some surveying. We have some satellite imaging being done, some ground LiDAR work we'd like to pay for. And this is terrible. I don't have the, gosh, I should put it up in the chat for everyone. There is a GoFundMe for us to go. We're already going. So here's the deal. We're going with or without it. But the ground LiDAR work is very expensive. And we're going to Belize, to an area that's never been explored in 40 years. It's been owned by one owner. It's very, very large. It's many square miles, and it's never been explored in modern times, and definitely not in the last 40 years by anyone, because the owner hasn't allowed anyone to ever do any research. So we're going to be the first research group, Jim, myself, a group of 11 other really great people, including Dennis Stone from America's Stonehenge, to Nikki Anna Jones, and Michael Roser from Dark Hour. He and I were we're working on some other documentaries. So Michael and I were like, hey, we should film this. So there's a lot that's going to happen, and we're going in April. And in order to get so for us to have 13 people lasered in to where we want to dig and look and make sure we know what we're doing and where we're going and what to avoid, we need some of this more expensive LiDAR work done. So we set up a GoFundMe, and it's under Belize Expedition, which personally, I've never done a GoFundMe thing, but it is under Belize Expedition, and descriptions there, the whole works. Be great if you guys want to support us that way. I can't really think of a better way to do it, but that is there. There are specific targets. If you ever want to email either Jim or I, please go ahead. There is very specific needs for the LiDAR and the satellite imaging, but we are on our way, aren't we?
Yep. Today's 16th, 30 days from now.
Holy crap.
Yeah.
Yeah, we got a lot going on. There's a lot of logistics. There's a lot of research. There's a lot of planning that is going on behind the scenes to make it happen. My new book is still coming out. I still think we can make it before the expedition. And there is just, it looks like it's going to be a great time for everyone going. And like Jim said, it's almost your birthday.
Yeah.
What are you doing?
78.
Can you believe it? And you're going to be in the jungle.
That would be Jungle Jim. Yeah.
Oh my gosh, that's not a bad name.
Well, there was a funny car racer, drag racer back in the 60s named Jungle Jim Lieberman. He had one of the first flip top funny cars, and I used to watch him race at Lions Drag Strip and Orange County International Raceway, and all sorts of fun places.
Well, what's the? I guess right now, I as far as anything else, I mean, that was a really great time with Dakota. Is there anything else we should be tabling, or should we let people go and do things?
Yeah, I have things I need to do, and I'm glad I realized that even though we're both mountain times at one time, I didn't go into daylight savings time, so I was an hour behind you.
Totally forgot about that.
Yeah. I remembered at the very last minute. That's when I came on right at the time we were supposed to come on. So
Yeah, for everyone else listening, for sure, on the record, Jim is always the first person here. He beats me. He beats everyone. So he gets a complete pass because he's always early.
yeah. So,
Well, let's say goodbye to everyone, and then we can talk for a minute offline if you're
Sure.
good saying goodbye to everybody.
thanks for signing on. We enjoy doing this. This is something I look forward to every week, and which is really ironic. When I was in Minnesota this summer, I was with Lynn Hurley, and I was doing a podcast with her on Wednesday. Was it Wednesday night or Monday night? One of those nights, and you were on. And I had just, like 2 days before I left Minnesota, came back to Arizona. All my family lives in Minneapolis. And we just sort of clicked. And it just, two Minnesotans. I wasn't born in Minnesota, but Minnesota's my home. And I don't think I'll ever be able to live there again. But my babies are there, and I have a couple of babies buried there, and I have a couple of ex-wives there too. So it's a warm place on my heart.
I'm glad it's more warm than scarred.
Yeah, this is true. Yeah. No, Shelley was wonderful. She was my first, and then the Antichrist, but that's beside the point.
There's our stopping point for everyone on air.
Right.
Thanks for joining us. Jim and I are going to talk offline.
Yeah, you have a good one, and we'll see you again next week. Take care.